Hey everyone, this is section 6.1, verifying trig identities. So when you're verifying trigonometric identities, you want to work on one side and you want to eventually make the one side look like the other side. So in this case, we're going to start on the left-hand side, which is sine x plus cosine x times cotangent. But we know that cotangent by definition is equal to cosine x over sine x. And it's a good idea to have your trig formulas handy. Here's the formula sheet, because you're going to need a lot of these identities. And you can find this in your module that's called, what is it called? I believe it's called formulas. So yeah, and unit circle, formulas and unit circle. You'll find that file there. Okay, so far we've gotten this. So if you continue, you're going to have sine of x plus cosine squared x over sine of x. I'm going to put a 1 underneath the sign so that I can find a common denominator. The common denominator would be sine of x. So I have to multiply top and bottom of this fraction by sine of x in order to get the LCD. And now I end up with sine squared x plus cosine squared x. And we know that that's a Pythagorean identity. That is equal to 1 over sine of x, which is equal to cosecant of x. And that is exactly what we needed to get to the right-hand side. That concludes that proof. All right, let's move on to the next one. So same idea. So we're going to start with the left-hand side. And instead of rewriting this, I'm not going to rewrite it. I'm just going to go ahead and multiply that out. I'm going to expand that out. So I have a tangent u times cosine. That's my first. Then I'm going to do the outer. That's tangent u times sine u. Then I'm going to do the inner. That's cotangent u times cosine u. And finally, last is cotangent u times sine of u. All right, so I'm going to rewrite these in terms of their identities. So tangent is sine over cosine. Once again, sine over cosine. And cotangent is cosine over sine. So those are identities that you really want to memorize because they come up so often. Cotangent is cosine over sine. And now let's see what simplifies. Well, the cosines here cancel. Not that one. The sines here cancel. And these we need to multiply. So we will end up with sine of u plus sine squared of u over cosine plus cosine squared of u over sine u plus cosine of u. Okay, so notice that you have two terms on the right side. So we have four terms. We need these four terms to turn into two terms. So we're going to have to combine a couple of these. I'm going to combine this one with this one, and you'll see why in a second. So if I put a 1 underneath, I'm going to group these two together. So the common denominator is sine of u. And that's the reason I decided on those two, because I want sine squared plus cosine squared, because that's equal to 1. So that's why I chose these two terms to combine. So let's go ahead and do that in the next step. So our common denominator is sine of u, and we end up with sine squared plus cosine squared. All right, now let's group these two together and do the same thing. Put a 1 underneath. The common denominator is cosine. So times cosine u times cosine of u. And we get same thing, sine squared u plus cosine squared u. And in both cases, those are equal to 1 over sine plus 1 over cosine. And we are trying to get cosecant plus secant, which is exactly what we got. Cosecant plus secant, which is equal to the right-hand side. So that was the strategy, is basically to expand and then to combine the terms that would make it work out and equal the right side. So the next one, let's see what we can do here. Don't let the 3 beta scare you. The 3 beta, you can actually just change that to x's, and it's the same exact problem, or theta, whatever you prefer. So don't let the 3 beta intimidate you. All right, so what can we do here? It looks like I would recommend rewriting. So let's start with the left-hand side. 1 plus cosecant 3 beta over 1 over cos. I'm changing the secant to be 1 over cos. And then I'm going to change the cotangent to be cosine over sine. All right, so if you multiply this by the reciprocal, you're going to end up with cosine 3 beta, 1 plus cosecant 3 beta, minus cosine 3 beta over sine 3 beta. All right, so now let's see what we can do here. I'm going to distribute, since that's the most logical thing to do in this case. So this is 1 over sine, right? So if that's 1 over sine and you multiply by cosine, you're going to have cosine over sine. What do you know? These two terms end up canceling out. They're opposites. And so a lot of times that's going to happen. You're going to be surprised and you'll see some terms that cancel, and then you end up with your desired result. In this case, cosine 3 beta is what we're looking for. That's equal to the right-hand side. All right, for this problem, the next one, as soon as I see tangent squared and I see secant plus 1, I think of the identity. Go to your trig formulas. Here's an identity. This is the one I'm thinking about. So tangent squared plus 1 equals secant squared. So let's go ahead and write that. Tangent squared plus 1 equals secant squared. Okay, so I'm going to subtract 1 because I want to isolate the tangent squared so I can do a substitution. So let's subtract 1. And so now we have tangent squared x equals secant squared x minus 1. So this is the identity I'm going to use. So I'm going to start with the left-hand side. And instead of writing tangent squared, I'm going to write secant squared minus 1, because that's equal to tangent squared. And on the bottom, I have secant squared plus 1. So now what I can do is, I know that this is a difference of 2 squares, and so I'm going to factor that. So if you factor it, you get secant x plus 1, secant x minus 1. That's the difference of squares. And the reason I saw that is because I saw the denominator was secant x plus 1. And so I said, if this factors, then I'm going to be able to cancel those 2 factors out. That's exactly what happened. So now we got secant x minus 1. It's getting closer to looking like that. Let's see here. At this point, we can rewrite this as 1 over cos. That's an identity for secant. And instead of 1, I can write that as cosine over cosine, because that's equal to 1. And now I'll have a common denominator, and guess what? I am done. And that is exactly what we needed to get the right-hand side. So sometimes you'll run into a dead end and you'll have to backtrack, but just don't give up. Just keep on trying different things. All right, and the more of these you do, the more techniques you will pick up, and the more experience you'll get. So in this case, let's see what we can do. This one's a tough one. This one's a pretty hard one. So I'm going to rewrite these in terms of their identities. So the left-hand side is going to equal to cotangent is cosine over sine minus sine over cosine. And of course, the denominator is going to stay the same here. Okay, so the technique I'm going to use in this case is I'm going to put big parentheses around the top and the bottom, and I'm going to multiply by the LCD. I'm going to multiply the numerator and the denominator by the LCD. The LCD in this case is sine theta cosine theta, but whatever I do to the numerator, I must also do to the denominator. Now I'm going to distribute. Actually, the bottom I won't distribute. You'll see why in a second, but the top I will distribute. So when I distribute, I get sines to cancel, and I get cosine times cosine, which is cosine squared. Minus, and when I distribute here, I get cosines canceling, and I get sine times sine, which is sine squared. And so now you might be able to see why I did not choose to distribute the denominator. The reason is because I have the difference of two squares in the numerator, which can be factored. So if I factor the difference of two squares, I'm going to get cosine theta plus sine theta times cosine theta minus sine theta, and I'm going to be able to cancel out one of those factors from the denominator. So you just have to have a little foresight. You have to keep your eyes on one step ahead to see what sort of technique might make the most sense. In this case, cancel, cancel, and then we are close to being done. So let's take a look at the next step. The next step is, well, let's rewrite what we have so far. This is what we have. In this case, if you look at the right side, you have two terms. So you want to turn this into two terms. It's a single term, but you can break up this fraction into two separate terms by doing this. You're breaking up the fraction into two terms. So cosine theta over the denominator minus sine theta over the denominator. And now you have cancellation, cancellation. And now you're going to have 1 over sine, which is cosecant, minus 1 over cosine, which is secant. And that's exactly what we needed. That is the hand side. That one was a tough one. This one, let's see what we can do. In this case, what I would do is I would rewrite these in terms of their identities. So left-hand side is going to equal to 1 over sine beta over cosine beta. That's tangent. Cotangent is cosine beta over sine beta. And then I'm going to combine these two fractions by finding their LCD. The LCD is sine, cosine, sine. So I need to multiply this one by sine, top and bottom, in order to get the LCD, and this one by cosine to get the LCD, which is going to be beautiful because we have sine squared plus cosine squared, which we know is going to be 1. All right, this is still over 1. So I was just combining the two fractions in the denominator, which I've done now. And now I have 1 over cosine beta sine beta. Notice I just used the Pythagorean identity to set that equal to 1. And now you're multiplying by the reciprocal. When you multiply by the reciprocal, you get cosine beta sine beta in the numerator, which is the right-hand side. These are reversed, but that's okay because multiplication is commutative. And that is the end of this section.